Hey guys. So instead of doing the usual data structures and algorithms course, LeetCode course that I usually do, I'm going to be doing a reverse linked list problem today because, I want to post a LeetCode problem every day. And the problem that I ran into is it's an early 1 a.m. and I want to understand the recursive solution for reverse linked list 2, but right now I'm just not able to intuitively like understand it. Um, So I decided that I would just do this for now, and I would continue with the course tomorrow. I'm just not able to get it right now. So I need more time to think about it tomorrow, and I want to sleep right now. So that's what I'm doing. Um, so yeah, let's do it. Reverse linked list. Given the head of a singly linked list, reverse the list and return the reversed list. So in example 1 right here, we're given the linked list 1, 2, 3, 4, 5, and we just return that reversed. How do we do this? Okay, so two things that we need to keep track of. At any point in time, at any node, we're going to have to keep track of the next node, and we're going to have to keep track of the previous node. Okay, why is this? Let's go over here. Okay, cool. So let's go over here to screen 2. Let me draw that real quick. So we have 1, okay, then we got 2, then we got 3, then we got 4, then we got 5. Okay, so we have 1, 2, 3, 4, 5, right? Great. Okay, so we want to keep track of head, okay? We want to retain where head is at. So what we can do is we can use a dummy pointer, okay? So we're going to have dummy is equal to head, okay? So that's going to be iterating through our entire linked list here, okay? So when dummy's at 1, okay, initially when it's at 1 here, first what we need to do is we need to set next node, which I'm going to call the nn, is equal to 2. Okay, we need to set that, and let me actually use a better color here. Nn is equal to 2. And also what I'm going to do is first, before we even start the loop, I'm going to also initialize the previous variable, which is going to be equal to none. So it's basically like a sentinel node. It's going to exist here. It's going to be like an n, okay? Not a list node. I'm just going to, so not list node none, just none, because then we'd return the list node in the reversed linked list, which we don't want. Okay, but now this too. We're going to pretty much create a variable called previous. Okay, it's going to be here to start with. Okay, so what we're going to do first is the first step, right, is in our loop, for example. Okay, so we want, okay, so before we even do that, let's clarify what loop are we doing. We want the dummy pointer, right, to start at 1 here and loop all the way to 5. And at each point, at every list node, we're going to take the pointer that list node is pointing to. So here, 1 is pointing to 2, and make it so that 1 is now pointing to previous, which the reason why I clarified that there's going to be a previous, like a previous variable that we're going to create is so that we don't get an error when I run this loop, because 1 has no previous, right? So we need to create this for that purpose, but it's also going to do more than just that. Okay, so at each point, we're going to take the pointer that it's pointing towards and point it in the other direction, okay? So first, before we do that, however, I want to make sure that dummy, right, the actual pointer where it's like where it's at, I want to make sure that we save its next location, okay, where it's going to be next, which is next node, which is why I saved as 2. Okay, so now 1 is now going to point to previous, okay? That's what we're going to do first. Now the next thing is 1's going to point to previous, okay? And after we point that to previous, Now, what I want to do is now I have to move everything up, okay? So now what I want to do is I want to move previous up, okay? And I'm going to move dummy up as well, okay? So previous would move up to 1, and dummy would move up to where next node is at. Get rid of that. But we're going to use next node to move dummy up there. Like, how else are we going to move dummy up? Sorry, terrible handwriting. I'm going to call it D, okay, for simplicity. D. We need that next node, a reference, to move dummy up there. And then we're going to continue that process, okay? We're going to save the next node. So basically, we're going to save next node, which is 3. And then we're going to point dummy in the direction of previous, okay, pretty much. And then after we point it, then we move previous and dummy up. Previous would move up using dummy as its reference, right? And dummy would move up using next node as its reference. And we'd continue that cycle until all of this is reversed from here to here. Everything is reversed. And when we return this, it's not going to return this none node because it's not node. We're going to clarify that previous is equal to like none. And that's not going to be a list node, not list node none. So this is not going to be part of our list. Okay, so let's code that. Okay, bet. Alright, so what we want to do here is previous is equal to none, and then dummy is equal to like head. So then while dummy, so that means while dummy is not none, what we're going to do, the first thing that we're going to do is we're going to save our next location. So next node is equal, I want to, yeah, OCD. Next node is equal to dummy dot next. And then, so dummy dot next is equal to previous. So basically why this is different here, why I do next node's equal dummy dot next and dummy dot next previous, because when it's on the right side of the equal sign, this is referencing the actual node, so the node that comes after dummy. But when it's on the left side, this is referencing the pointer, so where dummy points, where the pointer goes. So the dummy dot next, it's gonna go to previous, and then now we need to move everything up. So now previous is gonna be equal to where dummy is at, and then dummy is gonna be equal to like next node. And then at the end, oh yeah, I didn't clarify this. Wait. I want to clarify this. At the end here, we're going to return, well, what do you think we'd return, right? So if all this keeps moving up, right, until dummy has hit none, okay, then, okay, so, okay, wait. Until dummy hits none, everything is going to keep moving up, okay? So dummy, let's say dummy is here. Next node is dummy dot next, which that wouldn't exist, okay? Okay, let's just start here. Okay. Dummy's here, and next node, and then we got like previous. Okay. And then after this, dummy would move to where next node's at, and then previous, so dummy would move there, okay, and now it's gonna first get its next node, which that doesn't exist, and then it's gonna specify, we're gonna specify that dummy dot next is equal to previous, so it'd go to, so we'd route 5 to 4. Because previous would be here. So yeah, this would pretty much just keep going. So after that 5, after 5's routed to 4, then the next iteration, right, dummy would be none. Dummy would be equal to none. And during that iteration, during that exact iteration when dummy becomes none, we during the final iteration, previous would be where dummies at, right? Yeah. So basically, what I was trying to say with all of this, because I was trying to understand it myself. Okay, when dummy becomes none, because that's where the loop's going to, which is going to be 1 past 5. Word previous being our loop. Previous is equal to dummy. Okay. So, So, yeah. Okay. So if on the previous iteration, like, okay, so think about it like this, right? On our previous iteration, dummy would have been valid before it became none, and in our code we set previous is equal to dummy, and then dummy is equal to next node. So previous would be here, and then right after that we would set dummy is equal to next node, right? So now it becomes none, and the loop ends. But where's previous? Previous is here at 5, the last node, at the very last node. And when you return a linked list, you need to return the list from the head, because this is basically the head, because now the list is now going in this direction, right? So this thing here is basically the head, so we have to return starting from here at previous. Now if we return previous, then previous and everything previous connects to will also be returned. So we basically, what I'm saying is we need to return previous, because that points to the beginning of a reverse linked list. Cool. So then we'd return previous. Yep. So this is O of n time complexity, because we're just looping through the entire linked list with dummy. And yeah, since dummy's going to keep going from the head, dummy starts at the head, and it just goes to the very end of the linked list until it is equal to none. So yeah, that's O of n. And then the extra space would be O of 1, because we are not creating any new structures relative to the input. And that's the solution.